is just like it was with ax squared plus bx plus c. A will tell you whether the parabola opens, not in this case, not parabola, but a curve, opens up or not opens up, but kind of goes this way or is reflected over the x-axis. So if it's negative, it's going to automatically be flipped over the x-axis or reflected over the x-axis, which is the correct term we use. Okay? Now, let's say I want you to graph. We'll do this as an example. We're going to graph in this form, and we're going to call this example, really, truly example 1, because this really wasn't an example. We'll call this example 1. We're going to graph and compare. What are we going to compare our graph to, class? What do I still have left on the board that we're going to compare our graph to? Y equals the square root of x. Right, this parent square root function. Okay, we're going to compare our graph to y equals the square root of x. Okay, here's our graph. Y equals -2 times the square root of x. Okay, does it look so? Now, obviously, is this one in this form? What's my a? Positive or negative? Negative. So what's going to happen to the curve? It's going to be what? It's going to be going like this, or it's going to be reflected over the x-axis and going this way. Okay, because it's negative, it's going to be reflected. Okay? So let's put that down. We know that since a is negative, a is less than 0, it's going to be reflected over the x-axis. That's already one difference between our graph and y equals the square root of x. There's one comparison. Okay? We'll do the other here in a minute when we actually graph it. We'll see what's different. What do I tell you to do first, guys? Always make a what first? Make a table. Let's make a table. Okay, let's make a table. And what am I going to use for my domain? What number do I have to make sure I start with if only x is under the radical? 0, right. If there's more numbers under the radical, it doesn't necessarily mean I have to start with 0. So everybody start with 0 as your first domain. And what did I say would probably be the best numbers to use instead of 0, 1, 2, 3, and 4? What numbers?
1, 2, 4.
Perfect squares, right. 0, yep, you're both right. 0, 1, 4, 9, 16. Good, yep, good. All right, what is the square root? Now watch how I do this, guys, watch. So guys, let's go ahead and write our domain right now. What's our domain that we have to use? X is what? 0 and what? Greater, right? How do I write that as an inequality? X is greater than or equal to what number? So everybody write your domain down with me right now. You have to get used to writing that domain and range down. Don't forget that. Okay, now let's figure out what our range values is before we write down what the range is. Let's figure them out. Guys, put 0 in here for x. What's the square root of 0?
0.
0 times a -2. 0. Everybody got that with me? All right, now put 1 in here. What's the square root of 1? 1. What's 1 times a -2? -2. Everybody got that with me so far? You see how I'm doing it? All I'm doing is taking the square root first and then multiplying that number by the -2. Okay? Now put 4 in here, guys. What's the square root of 4? 2. Now what do I multiply 2 by? By -2. What's 2 times a -2? -4. Good. You can put this in your calculator, which equals. You can do that. If you want to do it in your calculator, watch. Go like this. Go -2 times the square root of 9. Just put it like that in your calculator, which equals. -2 times square root of 9. And which equals. What do you get? You get -6? You get -6? Good. You're doing it right. Good. All right? Right. Because what is the square root of 9? 3 times a -2? -6. Good. Now let's put 16. What is the square root of 16? 4 times a -2? -8. All right, good. We got our table filled out, don't we? Does that make sense, everybody? How do you feel about that so far? You feel good about the table? Now, what are we missing, though, before we go ahead and graph our curve? We're missing our range, aren't we? So we need to identify our range. So everybody put y here. Okay? Now tell me what's happening to the numbers in y. Are they getting bigger or are they getting smaller? They're getting smaller. What number did I start with, though? So everybody put 0 here. Make sense so far? All right, now what do we put, though, as our inequality sign? Greater than or equal to 0 or less than or equal to 0? Less than or equal to 0 this time, right? And this is our range. Good. All right, so we got our domain and our range. Now let's graph our curve on the same coordinate plane as this one. Oh guys, I'm sorry. Please do this, and I cannot believe I did it. Go back to your curve. What do I notice? If this goes on forever, what am I missing?
Arrow.
Oh my goodness, this is not a segment. We don't want, it's not a curve that doesn't stop. We have to be sure we put our arrow on the end there. We know that goes on forever in that pattern, in that direction. Okay, I'm going to use my same marker because it shows up better. Do you think red would work, Mrs. T?
Sure.
Let's try red, just because I want them to see the difference in the shape of the curve. All right, let's go ahead now and graph this one on the same coordinate plane as y equals the square root of x, and we'll see what our difference is. We already know this. This is one comparison, but we need to do another one. All right, so 0, 0 is obviously right at the origin. They both have the same origin. They both share the origin as their first point. But then we go over 1 and down 2. There's the next point on my curve. Then over 4, down 4. There's the next one. Then over 9, down 6. There's our next one. And then over 16, down 8. And there's our curve. Hold on, guys. A little shaky there, but. Okay, so there's our curve. Okay? So now, guys, tell me right now, what is another comparison besides the fact that we know it's reflected over the x-axis because obviously a is negative. So that's one comparison. We already wrote this down. But I want one more comparison between y equals the square root of x. What do you notice it is closer to? Is it closer to the horizontal axis or is it closer to the y-axis or the vertical axis? It's more towards what?
Why?
I can't hear you.
Why?
It's more towards the y, isn't it? Which is the vertical axis. So what do we call that when it's more towards the vertical? A vertical shrink or a vertical stretch? If this was, tell me this. If this was y equals 2 times the square root of x, wouldn't it look like this? Wouldn't that be y equals 2, wouldn't this be the graph of y equals 2 times the square root of x? Because it's positive? So tell me right now, if this helps you a little bit in terms of visualizing it, wouldn't this graph be more towards vertical? If I'm looking at it this way? Doesn't that mean that this is more towards vertical? It's more towards the vertical axis. So that's why we call it a vertical stretch. If it was like this, down here, it'd be a vertical shrink. But if it's more towards vertical, either if it's been reflected or not reflected, it's a vertical stretch. So we want to add that to our comparisons. This will be a vertical stretch. By a factor of what, though? Now, this is where it might be a little confusing. I did not put -2 there. Because when it's a vertical stretch, it's going to be the absolute value of A. What's the absolute value of a -2? So that's why we use the factor of 2. Because what's happened, guys, is you've taken that curve and you've multiplied it by 2 to make it more towards vertical. Okay, is what it's saying. Y equals the square root of x. So you understand, this is the graph of, just so you know, this is the graph of y equals -2 times the square root of x. That will be what the graph of y equals 2 times the square root of x would look like. It's been reflected over the x-axis because it's negative. A is negative. If it was positive, it would look like this. Okay? Does that make sense? All right. Let's go ahead now and do the next example. Now, the next one's going to be a little different. There's 2 more I'm going to do, and then that's it. Okay? Because that's what the ones you're going to be doing in your homework. Okay? So I got 2 more examples to do, and then we'll be done.